We're live. For those of you listening at home, hey Jonah. We are going through the L'Hopital's rule worksheet. I believe it's 8E-1. I don't know what it is. And Jonah, just for your reference, it's like super duper meat locker cold in here, so you're actually sparing yourself. I mean, it's a rough way to do it, I admit. But hopefully you're warmer than we are. All right, the answers are as follows. Number 1, the answer is 0. Number 2, the answer is 3/5. Number 3, the answer is 2. Number 4, the answer is 0. Number 5, the answer is 4. Number 6, the answer is positive infinity. Number 7, the answer is 0. Number 8, the answer is 1/2. Number 9, the answer is 5/3. Number 10, the answer is positive infinity. Number 11, the answer is 0. And number 12, the answer is 4. Repeats. All right, questions? You guys would like to see that something? Yeah. Number 3. Yes. The limit is x approaches infinity of x squared over x minus 1 minus x squared over x plus 1. Now, there are 2 ways to do this. You could split this into 2 limits. I did that, but you don't actually have to. Let me show you. I'll show you both ways to do it. The first way is to split it into 2 limits. So the limit as x approaches infinity of x squared over x minus 1 minus the limit as x approaches infinity of x squared over x plus 1. Now, this might or might not work. We'll just try it. This is the intuitive way. How do you take, this actually is kind of a pre-calc problem, believe it or not. We didn't have limits in pre-calc, but when you send x to infinity, when you make x bigger, 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 what objects do you find on a graph that way? What particularly exciting object? Asymptote. What kind of asymptote when you send x to infinity? What's that? Vertical. Vertical is when you're dividing by 0. Horizontal, right. If you send x to infinity, you'll see, if you're going further and further to the right, you're going to see if the graph flattens out or not. So, if you predict, do you remember how to do that? You only have to pay attention to particular terms.
Oh, the first.
Yeah, the dominant terms, the terms of the highest degree, usually the first ones. So this is the equivalent of saying the limit as x approaches infinity of x squared over x. Because the minus 1 is going to be so piddly by the time the x gets huge that you can just ignore it. Does that reduce? Yeah, to what?
X.
It reduces to x. So what happens as x approaches infinity to x?
Goes 1.
It goes to infinity.
Yeah.
This is kind of actually a dumb question. It says, as x goes to infinity, what happens to x? It goes to infinity. Didn't you just say that? Yeah. This is going to be a weird problem. Minus, you want me to do that trick here? Yeah, it's going to be the same thing if you reduce it as x approaches infinity of x squared over x, which is just x. So, okay. Infinity minus infinity, I caution you here.
Yeah, I put 0.
It's very, very tempting to put 0. However,
Tempted.
there are lots of different types of infinity. What's this infinity minus this infinity? Is there anything left? Yeah, quadrant 4, which is infinite. So in this case, infinity minus infinity is infinity. So you just don't know. I don't know how big, quote unquote, this infinity is, and I don't know how big, quote unquote, this infinity is. I mean, they're both infinitely big, but you could have zero, you could have non-zero. It's just really, really impossible to tell. Infinity, basically adding, subtracting, multiplying, and dividing, all break down when you have infinite values. So is there any other possible way to do this? Yeah. Find a common denominator. Crisscross across. By the way, the old-fashioned way is this thing needs an x minus 1 on top and bottom. This thing needs an x plus 1 on top and bottom. That's actually what crisscross across does. But let's multiply. Somebody multiply that out for me. So let me see. Equals the limit as x approaches infinity of what's that? X cubed plus x squared. And then distribute this one if you would. Yes. All over. What happened? Multiply these two.
X squared minus 1.
X squared minus 1. Does that make sense, bro? Now, again, I don't know if this is going to work either. This one was so tempting. It's kind of like a, I need a facial expression. Hey, by watch. I'm not going to tell anybody. Everybody's fine. Just, oh darn it, I don't have any props. Whatever. I was going to pull out a, cheap. Get splat for it. Okay, we're moving on. It's tempting. That's just a long, glorious, dramatic way of saying, don't fall for this temptation. Infinity minus infinity is 0. Maybe, maybe not. We can't make any assumptions about infinity. So, simplify this thing, if you would. Limit as x approaches infinity of what?
2x squared
Yeah, this cancels. 2x squared
over x squared minus 1.
over x squared minus 1. So, now try this. Try the trick with the dominant terms. It's the approximate. This is, if you reduce it, it's more or less what? I mean, this is irrelevant because these are so huge. It's going to be 2x squared over x squared, which reduces to what? There you go. That's your limit. And that was the only way we really managed to do it. Are there other ways to find the limit? Yeah. They're a little more desperate. It's like graphing it and hoping you see where it's going. If you graph this thing, the graph would keep flattening and flattening and flattening closer and closer to 2. But it's kind of hard to tell. If you say, is it flattening to 2 or is it flattening to 2.0001? There's no way to tell. Next. 5. Yeah. Okay. The limit as x approaches infinity. And by the way, there is, you did not have to do it, but if you did not remember your asymptote trick from last year, if you plugged infinity in, quote unquote, what would you get? Like, what would the answer look like?
Infinity over
Infinity over infinity. Guess what that authorizes you to use? Good grief, woman. L'Hopital's rule. Yeah, no, yes, you're right. We're gonna just, all the French people are gonna come and beat us senseless, but we're okay. So take the derivative of the top and the derivative of the bottom. What do you get? 4x over 2. 2x. Now take the derivatives again. 4 over 2, which is? That would have worked also. That's actually what the worksheet was expecting us to do. We just decided to be clever and do pre-calc. So, again, number 5 then. So the limit as x approaches infinity of 4 4x times sine of 1 over x. Now, this is kind of awkward, because what happens when x approaches infinity with 4x? Where does that go? To infinity. What is sine of 1 over infinity? Well, just what's 1 over infinity, basically? 1 over a huge, huge, huge number. It's basically 0. What's the sine of 0? That would trick people. What's that? It's 0. So what's infinity times 0? I don't know. In other words, we assume it's 0, but anything times infinity is infinity, and anything times 0 is 0, so we have kind of a war going on here. I have no idea who's going to win. So, does L'Hopital's rule apply to this particular case? There are only 2 times you can use L'Hopital's rule. Infinity over infinity and 0 over 0. And in neither of those cases is this. This is infinity times 0, which is, it has to be a little sneaky. What did I just do? Yeah, huh? What did I, is that weird? Prove it. Right, or some 1 over cosecant, right. Cosecant is the reciprocal of sine. So the sine of something is 1 over the cosecant. So I could have written it as 1 over the cosecant. Or, multiplying by sine is the same as dividing by the cosecant. Try it now. This is a little more frustrating to do in your head. But what would this give you? What's the top going to give you, first of all? If you try the limit. Infinity. Try the bottom. The sine, what's the sine of 1 over infinity? 0. Yeah, the sine of 0 is 0. What's the cosecant of 0? Ah, yeah, let's go back in time for a second. This is, go back in time, not the right time, date. Let's look at the unit circle for a second. What is the sine of 90 degrees, for example? Just off the top of your head. To 1. What is the cosine of 90? 0. Tangent of 90? It's undefined. It's a slope that's straight up and down. Why is it undefined? What causes that?
Because it's not a cosine.
Yeah, it's sine over cosine, so it's basically 1 divided by 0. Now, does anybody remember these? What is cosecant? Whoops, why did I do that backwards? I love this lexicon. Cosecant of 90. Yeah, take the reciprocal of the previous. What about secant of 90? Undefined. Because this is 0 over 1, basically. And what is cotangent?
0.
How do you get that?
0.
Yeah, it's the reciprocal of 1 over 0. So the reciprocal of 0 is undefined. The reciprocal of undefined is 0. And whenever, the reason they have undefined is you're dividing by 0. Look over here again. The sine of 0 is 0. What's the cosecant of 0? Undefined. What does that mean? There's another word for undefined which we did not use when we were first playing trig. The reason 1 over 0 is undefined, if you graph it, y equals 1 over x looks like this. Tell me, what's the limit as x approaches 0 from the right to 1 over x? Like, here's the problem. Dividing by 0. Well, what does that cause? What kind of an answer does that cause? Infinity. cosecant of 0 is basically infinity. Guess what we can use now? L'Hopital's rule. L'Hopital's rule. How does it work? Derivative. What's the derivative of the top? Yeah, the derivative of the top is 4. Let's see, anyone remember the derivative of cosecant?
Negative cosecant cotangent.
Yeah, negative cosecant cotangent. See what that does. By the way, do you ever remember what cosecant is again? I'm just sort of hoping we can simplify this thing. Because right now, it's going to be infinity times something, which I don't think will end well. You see what I'm talking about? It's like, yay, cosecant is infinity. Oh, yay, cosecant is infinity. It might or might not work, but let's see. Actually, let's just simplify it. Negative something times something. Okay, three people. What is cosecant again? 1 over sine. What's cotangent? Cosine over sine. This looks horrible. Actually. Simplify for me. On the top is 4. You're welcome.
And negative cosine of 1 over x over sine squared of 1 over x.
Yeah. Does that simplify anymore? How do you divide by fraction? The negative sine squared of this thing over cosine. So we now have negative 4 sine squared of this thing over cosine of this thing. Now remember, we're trying to do the limit as x approaches infinity. Let's see if it actually works this time. What is the sine of 1 over infinity? Well, what's 1 over infinity again, basically? 0. What's the sine of 0? 0 times negative 4?
0.
Okay. Now, if we get 0 over 0, we're still going to have a problem. This is 0, right? What's the cosine of 0? Finally, we got the answer. It is 0. There was one of the, wait a minute, they said 4.
Yeah, that's, I got
What is the name of all
Yeah, I
that
got
4?
0 as well.
Yeah. Let me double check on that one. That's suspicious. I mean, either I did something really stupid or the book is wrong. Can't be both. Anyway, never mind. I'll double check. Next. 11. Yes. 3 secant minus 3 tangent. The limit as x approaches is pi over 2. That's interesting. So what is pi over 2 really? What angle? Yeah, it's 90 degrees. 3 secant of x minus 3 tangent of x. Can we plug it in? Secant is what again? 1 over cosine. So I'm going to just rewrite this as 3 over cosine of x. And then what's tangent? Remember? Sine over cosine. 3 sine of x over cosine of x. Does anybody happen to remember the tangent at 90 degrees? It's undefined. Oh dear, that's going to be a problem. Which is going to be infinite. And then what's the secant? What's the cosine of pi over 2 or 90 degrees? 0. That'd be 3 over 0. Okay. So we have some version of infinity minus infinity. That's awkward. look at this form. I can't even use L'Hopital's rule on the top row because it's not a fraction. It's not infinity over infinity, it's not 0 over 0. See what we can do? You're actually sort of halfway there.
This consequence, oh.
Yeah, you could. Actually, you already have a common denominator.
Well then, yeah, just.
So 3 minus 3 sin of x. I just did the opposite, didn't I? Over cosine of x. So the limit as x approaches pi over 2. Now, what would I get if I plug this in? What is sine of pi over 2? 1. What times negative 3? Negative 3. What's 3 plus negative 3? 0. And what's the cosine of 90 degrees? 0. We at least have 0 over 0. Now what are we authorized to use? L'Hopital's rule. Let's do it. Take the derivative, take the derivative. What's the top derivative? The first 3 is just going to die, become 0. What's the derivative of this thing?
3,
Almost.
negative 3,
Negative 3?
cosine, what?
Cosine of x. Then what's the derivative of this?
Negative sine of x.
Yep. Now try it. What's the cosine of 90 degrees?
0.
0. Give me negative 3 times 0. And then what's the sine of 90 degrees? 1. Is that a legal fraction to use? Yeah. What do you get, by the way? You get 0 over 1, which is 0. Make sense? Anything?
Do you do 12?
Yeah. 2 e to the, what can I erase this stuff on the right hand side?
Yeah.
Okay. I have this haunting feeling that I missed something in that, but I'll figure it out later. Number 12, limit as x approaches 0. I'm just going to clear this with 2 times e to the x minus e to the negative x all over x. All right. If you plug in 0, what would you get? What's e to the 0? What's anything to the 0?
1.
It's 1, unless it's 0 to 0. Yeah, so this is 1. What's negative 0? 0. So e to the 0 is again 1. So what's this answer? It's 1 minus 1 is 0. 2 times 0 is 0 over 0. So it's 0 over 0. What are we authorized to do? L'Hopital's. Let's do it. Take the derivative of the top, derivative of the bottom. The top is actually not as, well, the bottom, here, I'll do the bottom for you. You're welcome. What's the top?
Is it that times 2?
Yeah, it's something times 2. What's the derivative of e to the x?
Yeah.
E to the x. What's the derivative of e to the negative x?
Just
It's e to the negative x, but there's chain wrong.
chain rule, yeah, times negative 1.
Times negative 1. So it's really negative e to the negative x. So what's the derivative of this thing?
Positive.
Plus e to the negative x. Does that make sense? Now let's try that. So 2 times, this is over 1, so that's going to be irrelevant. What's this going to give you again? Remember, x is going to 0. 1 plus e to the negative 0.
1.
1. So what are you looking at? 4. Got it. All right. Anything else? approaches zero. E to the two x minus one over something, 5x cubed. What do you get if you plugged it in right now?
Zero over, yeah.
You get 1 minus 1 on top, and you get 0 on the bottom. So 0 over 0. Ah, tell me what to do. Derivative. What's the derivative of the top? Be a little careful.
E to the two x times two.
Right, and then the negative 1 just disappears. So it's basically 2e to the 2x over what?
Over 15 squared.
Correct. Plug it in now.
Two. Wait. Zero, zero.
Well,
Well,
kind of, sort of. Try the 0 on top.
yeah, is that E to the zero?
This is,
Or
what's the top?
two.
It's 2. The top is going to be 2, and the bottom is going to be what?
Zero.
0. That's a little awkward. This is number 10, right?
Yeah.
Okay. Now, they, did they give a direction this is going to be coming from? I'll show you the graph in a second. But what does this remind you of? Whenever you divide by 0, you basically get what as an answer? Yeah, what's another word for that? Infinity. Now, take out your calculator, I want to show you something. Go to the y equals screen. Oh yeah, that's right. Does anybody have the r equals on their y equals screen? Okay, if they are, no pun intended, go to the 4th row down or something like that, and change it from polar to function. Back to the bottom.
Yeah.
Let me grab mine. Go to the formula for number 10 and type it into y equals screen. Do I have it in? Yes, I do have it in polar. Okay, so number 10, it's going to, by the way, you'll have to use parentheses around the top. Just type in e to the, oh, how do you get e to the power of? Anybody find it?
Yeah.
Second ln, right. E to the power of, and then 2x, close the little parentheses. Or if you have a fancy calculator, just hit the right arrow to get out of the exponent. Minus 1, parentheses, close parentheses. Then divided by parentheses 5x cubed. And then go to Zoom Standard and see what the graph looks like. Just wanted to point out, because one of the dangers we have is that if you have some number divided by 0, this is exploding, it's undefined, but it could be infinity, or it could be negative infinity. Both of them explode. It's really hard to tell which one you're going to. Look at the graph. As x approaches 0, does this thing have a limit? Yes, no? See who remembers chapter 1? When does a graph have an overall limit? When does a function have an overall limit?
Is it continuous? Well, does it not reach it?
Well, for example, this, I'm going to do y equals 1 over x. If I have the limit as x approaches 0 of 1 over x, here's the graph. As you approach from the right-hand side, it's going up. As you approach from the left-hand side, it's going down.
It's like,
The two sides have to agree.
So it's positive 50.
The two sides have to agree in order to have a limit. Does this thing have a limit at 0? It does. Where? Where's it going?
Okay.
To positive infinity, correct. Yeah, if they had both been swooping down, there'd be an overall limit at negative infinity. If they disagree, then there's no limit at all, then it would dissipate. So in this case, we definitely know it's positive infinity, because the graph is swooping up and swooping up. Just a detail on that thing. I think what you could do is you could keep taking the derivative on top and bottom, until there's absolutely no doubt. That's actually what I did. So we got this. The derivative would become 4 e to the 2x over 30x. And then it would become 8 e to the 2x over 30. Now just plug in your x equals 0. Actually, wait a minute. Alright, hold on. I can't do it. Oh, that's right, because, yeah, I couldn't do that, sorry, my bad. Because once it becomes 2 over 0, multi-class rule doesn't apply now. Never mind, just take the original one. I'm not gonna give you something that's very busting on the class note. It'll be relatively straightforward. I hesitate to ask if anybody's comfortable with that, but, everybody's still alive? Nice. What I would like to do, let me grab something off the photo out here. To show you.
Show you. Bye. What? After work. Working.
Sorry, that was a bad habit of continuing a sentence just as I walk out of the room.
You're gonna like keep continuing the sentence.
Yeah.
Take that.
I was tempted. I have something that, this is, version 1. This week, we're actually coming to the end of chapter 8.
That's a shocker.
So what I'm planning to do is give you 2 practice tests in a row. I'm gonna give you one today that you can work on in groups, then we'll go over it tomorrow. And then Wednesday, we'll have another one, a little more formal, where you just do it in your own. And then Thursday, we go over that, and then Friday, do you have any huge tests planned Friday, Dan? Oh,
Never.
what have you got? Okay, so, we'll plan on the chapter 8 test, try. And there will be this many questions, and then we'll throw a few extra prep questions on the back.
Well, this is your last test before exam.
I think so.
Yes.
Yeah. Any additional material? I'm not gonna do a separate test, I'm just gonna lump it with you.
Would it be like heavy on the exam, do you think?
The very last, like, the stuff from beyond this?
Well, yeah, so after this test, like, we're.
Okay, after this test, whatever extra material we cover, there will not be much,
Okay.
no. 1 or 2 questions maximum. Out of any, but you are welcome to start pounding away at that. Feel free to summon me to the board if anybody gets stuck. I'm gonna try and see what went wrong with that problem.
Yeah. Come on.
And, Jonah, we, praying for you, been there, so Godspeed your healing. Cheerio, y'all, Jonah. See you later.